Now we shall see two examples of limits. We shall use the L'Hospital rule for evaluating the limits. Before evaluating the limits, I again want to show the process of the L'Hospital rule. Friends, if limit x tends to a of fx by gx takes the form 0 by 0 or infinity by infinity, then we can apply the L'Hospital rule, and this rule is this one: limit x tends to a of fx by gx is equal to limit x tends to a of f dash x divided by g dash x. That means you have to differentiate the numerator and denominator where g dash x is not is equal to 0. Here we have used the notations: f dash x is equal to d dx of fx and g dash x is equal to d dx of gx. So the rule is this one. Again I repeat the rule: limit x tends to a of fx divided by g of x is equal to limit x tends to a of f dash of x divided by g dash of x, where g dash x is not is equal to 0, and we shall use this L'Hospital rule only when fx by gx, that means the type of the limit is of the form 0 by 0 or infinity by infinity. Now the first example is this one. Evaluate limit x tends to 0 of 2 to the power x minus 1 divided by root over 1 plus x minus 1. Okay, so we see that when x tends to 0, then the numerator is 2 to the power 0 minus 1 means 0, and the denominator is root over 1 plus 0 minus 1, that is again 0. So the form is 0 by 0. The form is of 0 by 0. So we can now use the L'Hospital rule. So what is the L'Hospital rule? Just we have seen this one. We have to differentiate both numerator and denominator with respect to x. So limit x tends to 0 d dx of 2 to the power x minus 1 by d dx of root over 1 plus x minus 1, isn't it? So we can write limit x tends to 0. What is derivative of 2 to the power x? This is 2 to the power x into log of 2 base e minus 0, derivative of 1, that is the constant, is equal to 0, and derivative of root over 1 plus x is 1 by 2 root over 1 plus x into derivative of 1 plus x, that is equal to 1. So into 1 we have no need to write 1, minus derivative of 1, this is 0. So we can write limit x tends to 0 to log 2 into 2 to the power x into root over 1 plus x. 2 into log 2 is a constant, so we can take it out of limit. So 2 log 2 into limit x tends to 0 of 2 to the power x into root over 1 plus x. So friends, we see that 2 log 2, and we have to apply limit x tends to 0, so it will be 2 to the power 0 into root over 1 plus 0. So we shall get 2 log 2 into 2 to the power 0 is equal to 1, and root over 1 is equal to 1. So 1 into 1 is equal to 1. So friends, what are we getting here? We get twice of log 2. Twice of log 2. It can be written log 2 square means log of 4. Okay. So the limiting value of limit x tends to 0 of 2 to the power x minus 1 divided by root over 1 plus x minus 1 is equal to log of 4. Now we shall see the next example. Our next example is evaluate limit x tends to 0 log of 10 square 2x base 10 square x. Here we shall use the property of logarithm. We know that log of m base n can be written as log of m base e divided by log of n base e. Okay, so this limit can be written limit x tends to 0 log of 10 square 2x base e divided by log of 10 square x base e. Now since x tends to 0, so tan 0 is 0, so log of 0 is undefined, and here also in the denominator log 0 is undefined and it is going to positive infinity. You know the curve of logarithm log x. You know the curve of log x is this one. It is passing through the point 1 0. So when x is tending to 0, then the curve, that means y is equal to log x is tending to positive infinity. So the type is of infinity by infinity. Okay, so obviously we can use here the L'Hospital rule. So the limit x tends to 0 ddx of log of 10 square 2x divided by ddx of log of 10 square x. So this is equal to limit x tends to 0 1 by 10 square x 10 square 2x into 2 tan 2x into sec square 2x into derivative of this 2x, that is 2, divided by derivative of log of 10 square x, that is 1 by 10 square x into 2 tan x into sec square x. So here we can write this as 2 to the 4, so outside of the limit, and here also 2, so this is also outside, so 4 divided by 2 into limit x tends to 0 sec square 2x divided by 10 2x divided by sec square x divided by 10x. Okay, so in the next step we can write this is equal to 2 limit x tends to 0 sec square 2x can be written as 1 by cos square 2x into 10 2x can be written this 10 to 1 by 10 2x means cot 2x, so cot 2x can be written cos 2x divided by sin 2x, and this sec square x divided by 10x can be written as sin x by cos x into cos square x, because this x square is in the denominator, so we can, if we take it on the numerator, so it will be cos square x. So now this is twice limit x tends to 0 sin x into cos x divided by sin 2x into cos 2x. So we can write here twice of limit x tends to 0. We change the page here. Twice of limit x tends to 0. We multiply both numerator and denominator by 2. So 2 sin x cos x divided by sin 2x into cos 2x. So this is twice limit x tends to 0. 2 sin x cos x means sin 2x divided by 2 sin 2x into cos 2x. Sin 2x is cancelled. So we can write here x is tending to 0. X is tending to 0. Therefore x is not is equal to 0. So sin 0 is not is equal to actually when x tends to 0, then sin 2x is also tending to 0. This is not is equal to 0. So we have cancelled here sin 2x. So this can be written twice of limit x tends to 0, 1 by 2 into cos of 2x. Now apply the limit. The limiting value will be now in this way. 2 into 1 by 2 cos 0 is equal to 1. So 2 is cancelled here. The result is 1. So the limiting value of the given form, that is, the given form is this one. The form is limit x tends to 0 log of 10 square 2x divided 10 square 2x base 10 square x is 1. Again I repeat, limit x tends to 0 log of 10 square 2x base 10 square x. The limiting value is 1. We have applied here the L'Hospital's rule because the form is of infinity by infinity. So it is better to apply the L'Hospital rule, and using this one we get the result 1. That is the limiting value of this problem is 1. Thank you. Have a nice day.